my dear student, I'm Saktwala from PROERTIES. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of properties of matter for our subtopic of the surface tension. So before we proceed with our discussion here, we are supposed to remember where we ended on the last session. On the last session, we tried to see how can we get the radius of the line of the single dropsy. And we said that for the liquid dropsy, we get R of the single liquid dropsy by taking by taking the radical of R1 square plus R2 square plus R3 square plus dash the nth terms of R square. That is what we tried to see. But for the second part, we try to see the coalescence of the soap bubble. And we tried to demonstrate the formula of getting the soap bubble by saying that the radius of the interface must be equals to them must be equal to R1 times R2 divided by R2 minus R1. That is what we demonstrated on the last session. But for our today discussion, we are going to proceed for our third part, which is related with the coalescence of the liquid dropsy. So here we are going to see a breaking of the liquid dropsy. Firstly, we try to look about the coalescence. Coalescence ni kama muungano, kwamba vitu viwili vikiungana, atom mbili zikiungana au molecule mbili zinapoungana zinakuwa zinatengeneza molecule moja. Sasa hapa tunaenda kuangalia the breaking of that liquid dropsy. That what the result can happen when we have the single liquid drop, and that liquid drop, my dear student, break together, breaking down, and after being breaking they form the single dropsy. Sasa ni kitu gani ambao kinakuwa kinatokea? How can we get the formula related with what we are going to see for our breaking of the liquid dropsy? So when a larger liquid dropsy is subjected to the external pressure greater than it is a pressure holding its molecule. So imagine that when we have the larger liquid dropsy, and that larger dropsy, my dear student, is subjected by the pressure which is greater than it is pressure holding. Kwa ile imebini subjected by the pressure greater than it is pressure holding of it is a molecule. So it breaks into small dropsy. So that liquid dropsy which is subjected by the external pressure, now it breaks into small drops. Kwa ile itavunjika kwenye vipande vidogo vidogo, vitone vidogo vidogo. When the drop of the radius R break into small drops, now each of radius R there is an increase in the surface energy. Kwa inapokuwa na break, basi itapelekea ile surface energy iweze kuongezeka, lakini ile volume itaweza kuremain constant. That is what we are going to discuss for our today discussion here. So let the drops break into a small identical dropsy. Kwa sasa tuassume kuwa we have the drops, and that a drop break into two small identical dropsy. Kwa sasa tuashumu tuna hii dropsy. Sasa hii dropsy ime break, we have the dropsy, and that dropsy, my dear student, break into identical dropsy. So the increase in energy, this increase in energy must be equals must be represented by symbol W, and this will be equals to the surface tension. Then we times it by the surface by them the increase of the surface area, as we see here, kwamba ituweze kupata surface energy tutamchukua ni sawa na surface tension, alafu tutazidisha na yule surface area, where this surface this derivative of A is the increase of in the surface energy. Kwa huyu symbol hapa ata represent the increase in the surface energy. So original surface area of a larger dropsy is 4 pi r square. Therefore will be equals to 4 pi r square. Kwa huyu surface area wa mwanzoni sasa atakuwa ni sawa na 4 pi r square. And that of the two dropsy is twice the area. Sasa kama yule original, kwa sababu mwanzoni tulikuwa na surface dropsy moja na ile imevunjika kaweza kutupatia dropsy mbili. Sasa tuashumu kwamba ile first one the first one which breaking formula yake ya kutafuta surface area itakuwa ni sawa na 4 pi r square, lakini wale wengine watakuwa ni half, watakuwa kama alivyosema hapa that of the two drops is twice the area. Kwa that of the two drops atakuwa ni twice of that of one drops. Kwa wale wengine atakuwa ni mara mbili wa ile ya mwanzoni kama tunavyojaribu ku observe. Kwa hiyo itakuwa ni twice wa wale wengine. Therefore we should say that in order to get the surface area for breaking of the breaking of the liquid drops, we should say that the increase in the surface area must be equals to 8 pi r square, then we minus by 4 pi r square, the capital letter r square. Kwa nini tumesema hapa ni 8 pi r square? Tumeona kwamba for the small droplets, kwa sababu huyu mkubwa ndo amevunjika. Sasa for the small droplet yule aliyevunjika it means ameganyika mara mbili. Kwa hiyo tutakuwa na surface area mbili. Ndio maana akachukua ni 4 alafu akazidisha na original ile ya surface area. Mwisho wa siku, lakini radius yake ilikuwa ni least kwa sababu ni vipande vidogo vinavyofanana, ni two identical droplets. Sasa tutamwambia kwamba ili tuweze kupata increase in the surface area must be equals to 4 pi to 8 pi r square minus the 4 pi r square, the capital letter r. This will be our formula here. So it then follow that. Now it follow that, my dear student. So from our formula which said that the surface energy is equal to the surface tension times the surface the increase in the surface area. Now we are supposed to take this value and substitute instead of writing the increase in the surface area, we are supposed to write 80 pi r square. Then we minus by 4 pi capital letter r square, as we seen here. Now finally we should conclude by saying that the surface the work done or the surface energy must be equals to the surface tension multiplied by bracket 80 pi r square, then we minus by 4 pi r square, the capital letter r, and this will be our equation number 5 for our 6th topic here, as we see, my dear student. So generally, if we drop a break down into any equal droplet, sasa tuassume kwamba ile single droplet sasa imevunjika, kwamba ime break into the several stems, kwamba imevunjika mpaka ikatengeneza vipande vidogo. It means several identical droplet. Now how can we get the work done? This is what we are going to try to observe, my lovely student, as we see here. So for that concept, because we have said that from work done is equal to the surface energy bracket this 80 pi r square minus 4 pi r square, which expresses about the difference between the single liquid droplet and also the two identical lane droplet liquid drops. Since the volume is constant, as we know that the volume remain constant when those are breaking down. Kwa kama volume ita remain constant, sasa concept ambayo tutakuja kuitumia, tutasema kwamba the volume of the single lane droplet must be equal to V1 plus V2 plus V3 plus dash to the end stems of that lane liquid droplet. Kwa tukisha substitute pale formula ya volume ambayo ni 4 over 3 pi r cube. Kwa tukisubstitute kwenye a single lane droplet tutapata ni 4 over 3 capital letter r cube. then equal to 4 over 3 pi r1 cube. Then we add by 4 over 3 pi r2 cube. Then we add by 4 over 3 pi r cube. As we seen here, we add dash 4 over 3 pi r instems cube, as we seen here, my lovely students. So after this one, now because we have the common value, the 4 over 3 pi is present on both sides. Now we are supposed to factor it out. Kwa tunataka tuweze kufactor out it out. Kwa tukisha factor out, tutapata 4 over 3 pi r cube must be equals to 4 over 3 pi bracket. To r1 cube, we add by r2 cube, we add by r3 cube, we add by dash r nthems cube, as we seen. Now we should cancel the common value that are found on both sides. To cancel 4 over 3 pi, 4 over 3 pi, and finally we should obtain that r cube must be equals to r1 cube plus r2 cube plus r3 cube plus dash rn cube. Now finally, my dear student, but for identical, as we have been told that those are small droplet that come from the single droplet that happen due to the breaking of that single droplet must have the same radius because are identical. Kwa kama ni identical, basi tutaconclude kwa kumwambia kuwa kumbe R1, R2, R3 pamoja na instems watakuwa ni the same. Kwa wakiwa the same, basi formula ambayo tutaipata pale itakuwa ni 4 over 3 pi r cube equals to nth terms, kwa sababu ni the same nth terms of times the 4 over 3 pi r cube. This is what we try to observe, my dear student. So kwa sababu hao wanafanana, basi tutacancel out. Tutaenda tuangalia kwenye next slide.